The data below represents yearly car insurance premiums in the U.S. for 17 randomly selected drivers. Assuming the data is normally distributed, test the claim that the average yearly car insurance premium for a person in the U.S. is $1,613 using a level of significance of 10%. So let's see. The first thing that we need to do when we're testing a claim is find out what type of test we're going to be using and whether that test is justified. And that's actually the first couple of problems here, the first couple of questions we need to answer, that is. And to determine that, a great way is to parse out what the claim is from the about the population. So it says here to test the claim that the average yearly car insurance premium for a person in the U.S. is $1,613. So that means that the claim about the population is the mean is equal to 1,613. So that right there, because we're testing a mean, tells us that the type of test is a test for the mean. But we need to be a little bit more specific. We can either test for the mean using the normal distribution or the t-distribution. And what that comes down to is the population standard deviation known? So digging through the information, at no point were we given a population standard deviation. We could derive a sample standard deviation from this group of sample data, but we don't have a population standard deviation, which means we can't use the normal distribution, so we use the t-distribution instead. And now it's not set exactly that we can use the t-distribution as of yet. We need a couple more things to happen. In particular, we need the central limit theorem to be satisfied. And to satisfy the central limit theorem, you either have to make sure you're using a sample that is bigger than 30, or pulling data from population that is normally distributed to begin with. So our data set is not very big. I definitely would not say that that's more than 30 items. So what we need is the data to be normally distributed. So that's why we have this statement right here. Assuming the data is normally distributed, that's great. So that can tell us that we are allowed to use the t-distribution. So the evidence that justifies the use of the test, well, walking through here are the options. We've got, there are two different samples being compared. That's not true. The original population is approximately normal. That is true. All right, that helps justify the use of the t-distribution. Sample size is larger than 30. That's not the case in this situation. The sample standard deviation is not known. We can come up with that because we have the sample data. The population standard deviation is known. Well, that's not true either. But this next one is true. The population standard deviation is not known, so that tells us that we're using the t-distribution in general. And this last item is actually something that is a requirement for binomial distributions, so we'll leave that off. All right, now we're ready to start our test. And the first thing that we need to do is take our claim and express it in the form of a hypothesis. And to make it the form of a hypothesis, we have to decide if it's going to fit into what's called the null hypothesis or the alternative hypothesis. And because there is a statement of equality, it's just mu equals 1,613. That falls under the null hypothesis. If there were no statement of equality, if it was not equals, less than, or greater than, it would be an alternative. So I'll go ahead and mark that was my claim and fill in the alternative with the complement. All right, is the original claim located in the null or alternative hypothesis? Well, the original claim is in the null, so we'll just put that as H0. What is the critical value for the given statistics? And that's actually miswritten there. That shouldn't be critical value. That should be test statistic. And that is a value that we're going to get from the calculator. So let me go back to my sample data, and we'll derive the test statistic from the calculator using that sample data. Now, it's going to take a little bit of time to type in all of this information, but what I need to do is I need to put it into a list. So I'm going to pick L1 and just start entering the data item by item into L1. And because it's going to take a moment, I'm going to pause the video and restart when I'm done. Okay, have all my data in. Now I'm ready to calculate some statistics. So I will go under the stat key and over to tests. That's where I'm going to find my hypothesis tests. Now we've already decided that we're doing a t-test, so let's pick that option. Now this time we do have our input coming from a set of data, so I'm going to switch over to that other input mode. And all we really need, besides the place where the data is located, is the population mean from the null hypothesis, which is 1,613. The data itself is in list 1. I could do the mean and standard deviation on my own and then copy that information over, but it's just as easy to reference the data and allow the calculator to do the mean and standard deviation for me. And the last thing I need for this calculation is the symbol that was used in the alternative hypothesis. And that was a not equals, so this is a two-tailed test. So I'm going to select that and press calculate. And the test statistic is the second item that comes up here, so negative 2.597. Okay, now the next item is the p-value for the test. The p-value is also given in the output of the t-test. That's just the next item down, so 0.0194. What is the decision based on the given statistics? So the decision, the way we make that, we have our p-value that we just came up with, which is 1.94%. And then we have our level of significance, and that was given originally in the problem. I just need to scroll back up and find out what that is. So the level of significance, sometimes it's called alpha level, and that's 10%. That's what we're going to compare our p-value to decide if we have enough evidence to reject or fail to reject. And the rule is, if p is low, the null must go. So if the p-value is less than alpha, then we reject the null hypothesis. And that's what we're going to do in this case. So the decision is to reject the null hypothesis. And what is the correct interpretation of this decision? So using a 10% level of significance, there is sufficient evidence. And the reason I chose is here is because reject the null hypothesis is a strong result. So we put stronger language here. So is versus is not. If we had failed to reject the null hypothesis, we would have put is not. Sufficient evidence to, whoops, there's no blank here. We need a blank. This is either going to be support or reject the claim. And to come up with that, let's scroll back up and see where the original claim lies. So the original claim is in the null hypothesis. And in that situation, we're trying to reject the claim. So we are trying to reject. And in this case, at the 10% level of significance, there is sufficient evidence to reject the claim that the average yearly car insurance premium for a person in the US is $1,613.